Hello and welcome to Food Safety Fridays. My name is Simon Timperley from the International Food Safety and Quality Network. Today's subject is radiation safety compliance for X-ray inspection systems. And today's presenter is Dave Leith, Compliance Officer from Eagle Product Inspection. So welcome, Dave. Nice to have you here for your first visit.
Yes, good morning and good afternoon.
Yeah, so I'm in it's actually sunny Lancashire. And whereabouts are you joining us from today, Dave?
I'm in sunny Thrapston today.
Very nice. So sort of opposite ends of England. You tell us where you are in the sidebar. Let us know as you do. Zin Myo Sway from Thailand, Michael from Zimbabwe, Jeanette from Texas. Lovely to see. All over the world. I'm going to play the video ads now for a couple of minutes. We'll be back for the presentation in a couple of minutes, okay? Just bear with me. Okay. Okay, get the presentation. Yep. All good. Right. I'll be back for the Q&A later, but for now, I'll hand you over to Dave.
Hi all, welcome to Radiation Safety Compliance for X-ray Inspection Systems. I'm Dave Leith. I'm the Compliance Officer at Eagle Product Inspection, and I'm responsible for ensuring that Eagle's X-ray inspection machines meet radiation and safety compliance. I'm also working to increase safety measures where needed within the company and in the machine builds. I have over 40 years of combined engineering and quality experience, having held many qualifying engineering roles throughout my career. Starting at the Royal Air Force as production and quality engineer, followed by quality and maintenance engineer at Gas Hydraulics, quality roles at Lockheed Martin and Safeline X-ray. I hold in City and Guilds in aeronautical engineering from the Royal Air Force, and have certifications for Six Sigma Green Belt, and I have qualifications in European machine safety requirements, risk assessment, and last December I completed a certified machine safety expert course run by the TUV. This is the agenda for this afternoon. X-ray inspection of food is safe, safety regulations, installation compliance, standards for radiation protection, RSO, RPA, and RPSs, safety design features, and a Q&A session. X-rays are an invisible form of electromagnetic radiation. Like light or radio waves, they're part of a single continuum known as the electromagnetic spectrum. Since X-rays have shorter wavelengths, higher frequencies, and higher energy than visible light, meaning that they're able to pass through materials that block visible light. The transparency of a material to X-ray is broadly related to its density. The denser the material, the fewer X-rays that pass through. Hidden foreign bodies like glass or metal show up under X-ray inspection because they absorb more X-rays than the surrounding product. X-rays used in food inspection systems should not be confused with radioactive materials such as uranium. Radioactive materials are physical sources of radiation. They emit radiation continuously and can't be switched off. X-ray used in food inspections are different. They can be turned on and off at will. Common measurement types. There's always some confusion about the measuring units. Gray, a unit of absorbed dose of ionizing radiation defined in the 1980s. Rem, a Rankine equivalent man, a unit of effective absorbed dose of ionizing radiation in human tissue. Rad, absorbed radiation dose, which is a unit of absorbed ionizing radiation. And Sievert, the SI unit for ionizing radiation dose. These are all measures of the health effect on low levels of ionizing radiation in the body. X-ray and doses. All living creatures from the beginning of time have been and are still being exposed to radiation. This radiation comes from two sources, which are natural background radiation and man-made sources of radiation. There are three sources of natural background radiation. Cosmic radiation. The Earth and all living things on it are constantly bombarded by radiation from space, similar to a steady drizzle or rain. Terrestrial radiation. Radioactive material is also found throughout nature, in soil, water, and vegetation. Low levels of uranium and thorium in rocks and soils. Radon gas, created when the natural radioactive uranium and thorium slowly decays in the ground under our homes and seeps to the surface. Because of the way we heat and ventilate our homes, some radon gets indoors through the floor. This is where we get the most of our radon exposure. Internal radiation. In addition to cosmic and terrestrial sources, people also have radioactive potassium-40, carbon-14, and lead-210, and other isotopes inside their bodies from birth until death. Every human on average receives a dose of 2.4 millisieverts a year from natural sources of radiation, and about the same from artificial sources such as medical X-rays, CT scan, radiation therapy, and from nuclear facilities. The average dose received from a single chest X-ray is about 20 microsieverts. Air travel also increases your radiation exposure. A return flight from London to New York is normally about 100 microsieverts. The typical dose rate immediately adjacent to an X-ray machine is less than 1 microsievert an hour. So that brings us to safety regulations surrounding the use of X-ray as a means of product inspection. Food X-ray inspection equipment is regulated to ensure that it's safe to use, and X-ray systems must comply with local rules and regulations on the use of ionizing radiation. Such regulations vary from country to country and from state to state. Europe overall is stricter than the United States or Canada with regard to radiation emission limits. US regulations specify, for example, that the maximum line radiation leakage level should not exceed 5 microsieverts an hour at 5 centimeters from the X-ray system. Europe, after the analysis of the ionizing radiation regulation 2017 in the UK and the Euratom 2013, the limit for the effective dose for public exposure is 1 millisievert in a year. The European industry decided that radiation measurements taken from a machine should be based on the assumption of a yearly dose of an individual working on a machine at a standard amount of time. 8 hours a day, 40 hours a week, 50 weeks a year. In the case of X-ray systems, it is considerably less, as machines can run automatically. They can be manned 20%, 25% of the time. And we calculated it at 50%, which is considered worst case. This equates to 1,000 hours exposure a year. When calculated, we end up with a figure of 1 millisievert per year. As with most instruments measure microsieverts, it is logical we measure a machine in microsieverts per hour. It is important that X-ray inspection equipment is regularly tested and certified to meet these safety standards. Service technicians in the US can verify compliance using radiation detection instruments, which are being calibrated to a national standard. This is the same in all other countries. Installation compliance. When using X-rays for product inspection, the X-ray system must be installed to comply with the local rules as well as regulations on the use of ionizing radiation for the country in which the machine is being used. It is recommended that the installation is only carried out by a qualified service engineer. Once installed, all the X-ray systems are subject to a final critical radiation survey to prevent accidental exposure. If they pass, a certificate is issued. The survey should be undertaken by the Radiation Safety Officer, the RSO in the US, or the Radiation Protection Supervisor, RPS in UK, who will act as the point of contact for any X-ray safety questions. X-ray system manufacturers are required to provide the purchaser with manuals and instructions which provide both technical and safety information. Before operation, it is important that all staff are trained in the proper use of X-ray equipment and its relevant health and safety issues. Standards for radiation protection. The Nuclear Regulatory Commission, the NRC, oversees the use of radioactive materials and sources of radiation and establishes the standards for protection against radiation in 10 CFR 20. A total of 39 states have entered into a contractual agreement with NRC to oversee the use of radioactive materials and sources of radiation within state boundaries. Most of the standards for protection against radiation regulations are not applicable as cabinet X-ray systems do not contain any radioactive material. Standards for radiation protection in other areas. Australia has Radiation Health Series 21. There's been a new requirement quite recently where they require pre-registration of the generator in the state. Canada, the Radiation Emitting Devices Act, commonly called the RED Act. There's no submission, but the machine must comply with the RED Act. Ontario, pre-start health and safety reviews require a declaration from an engineer on the safety of the machine and a risk assessment sent with the machine. France, NFC 74100. The machine is tested by a third party for radiation emissions, control and generator testing. Spain, UNE 73302. Homologation. This is a paperwork submission for the Spanish government so that a machine can be used in Spain. Generally takes about 3 months for it to be processed. The United States have CFR 21 Part 1020.40 Cabinet X-ray Systems, an online form submission to FDA. After submission, they will send out an accession number for the machine, which is important to keep a record of because it may cause your machine to be held up in customs. RSO, RPA, and RPSs. Radiation Safety Officer, RSO in the US, is a person within an organization responsible for the safe use of radiation and radioactive material, as well as regulatory compliance. Radiation Protection Advisor, RPA in the UK, trains radiation supervisors to enable them to carry out radiation surveys, critical examinations of X-ray machines. A radiation protection supervisor is appointed for the purpose of securing compliance with the Ionizing Radiation Regulations 2017 and ensuring that the local rules are enforced. All countries have something similar. X-ray inspection before and during processing. Typical X-ray inspection systems used before food processing are bulk flow and pipeline X-ray systems. During chicken processing, after the deboning process, conveyorized X-ray systems such as Eagles can ensure that bones have been removed from chicken breasts. Foreign bodies can also damage processing equipment, leading to downtime, costly repairs, and additional metallic foreign bodies from damaged equipment. Mechanical processing, such as grinding raw incoming meat for sausages or burgers, can cause foreign objects to break up into smaller pieces, making them harder to detect. Another reason to install X-ray inspection systems at critical control points is to ensure that these contaminants are caught before the final product is shipped or before they cause damage to downstream equipment. Processing also changes the nature of the product, often making it more difficult to find foreign bodies. Cooking can produce chemical changes that alter the density of physical foreign bodies. For example, in ready meals or in cooked bones, the density of cooked bones, for example, is much lower than that of uncooked bones. When bones are cooked, the collagen in them breaks down, weakening the bonds that hold the calcium together, making the bones harder to detect. The change is most pronounced in poultry bones, and it's only with advanced detector technology that you're able to distinguish between cooked and uncooked bones. Now let's look at the design and safety features of an X-ray system, as well as the regulations that cover X-ray inspection equipment. An X-ray inspection system consists of 3 key components: an X-ray generator, a detector, and a computer to analyze the X-ray image. The whole assembly is encased in a stainless steel X-ray cabinet. The system is equipped with a stack light that may be seen from 360 degrees around the machine. The stack light is mounted on the top of the system typically. Red equals X-ray on, yellow equals fault light, green equals power on. The lamp stack is wired to a safety circuit. If the lamp fails, the X-ray source automatically switches off. All access to the primary beam radiation is protected by interlocks and monitored by a safety relay. I thought it appropriate to explain how an X-ray tube works, take some of the mystery out of it. The X-ray tube consists of a cathode A and an anode C, inside a glass envelope evacuated to a negative pressure. A tungsten filament cathode boils out electrons, which are then accelerated B to the target by high voltage. X-ray tubes have a limited life that is dependent on how they are used. A tungsten filament is 0.2 millimeter wire wound in a helix and inserted into a cup, which is used to focus on the target. The tube filament needs to heat up to approximately 2000 degrees C before the tungsten can freely admit electrons. The picture shows the coil in the cup on the left, and the coil is removed from the tube on the right. This was from an Aracino tube. With sufficient energy and heating the cathode ray filament, it releases electrons into the vacuum chamber. The applied voltage accelerates electrons to the target at the cathode. The change in momentum causes release of heat and the release of X-ray photons, and the X-ray photons become your X-ray beam. X-ray systems are safe by design. Shielding of equipment is the most common way to control emissions, and is entirely within the control of the X-ray system manufacturer. The denser the material, the better the shielding effect. As in many cases, machines may be in a harsh, wet environment. That's why X-ray machines tend to be made of and encased in stainless steel. The aim is to keep the primary beam encased in the generator and the collimator. Higher absorption materials can be copper, brass, or even lead, which we are currently replacing due to the requirements of ROSH, or special alloys developed for radiation shielding. With adequate shielding, an X-ray inspection system poses no health risk to operators. Numerous other design features enhance the safety of X-ray inspection systems. Standard safety features include a safety interlock design and tunnel curtains to retain emissions. The X-ray system can also be fully integrated with the manufacturer's production line safety circuit if required. Other features include lockable power isolators, accessible emergency stops, and a top-mounted stack light with 360-degree visibility. The manufacture and the installation of the X-ray system is subject to regulations, which ensure the equipment is safe to use, even if the operator is required to stand next to the machine every hour of their working day. Once installed, the X-ray system will have a final critical X-ray survey. If it passes, a certificate can be issued. This is done by the X-ray system manufacturer or by an independent inspector, depending on local regulations. Before starting work, all operators must be trained on the proper use of X-ray equipment and understand relevant health and safety issues. X-ray equipment suppliers can support U.S. companies with radiation safety and regulatory compliance by offering radiation safety training packages. Training includes licensing and registration, radiation safety and development, and implementation of radiation protection programs. E-stop, a supplementary device. The purpose of an emergency stop function is to avert actual or impending emergency. Situations arising from behavior of persons or from an unexpected hazardous event. Interlock conveyor access panel, protection from primary X-ray beam and scattered radiation. Allows access to the inspection zone for cleaning and removal of product jams. Interlocked right and left louvers. Access to the conveyor for cleaning, removal of product jams, and belt replacement. Interlock cabinet front access panel and rear access panel. Access to the generator, detector, computer, and other key electronic devices for servicing. And this is an overview of the complete systems. An example of a safety system visualization. The safety controller is connected to the PC. This allows the Simultask software to communicate with the controller. Simultask has been programmed with a visualization features that allows the user to see the fault that has occurred. This visualization consists of two views of the machine, front with access panels closed and rear with access panels open. Each device is represented by an icon that changes state depending on the action that has been taken. It may also indicate machine overtime, water flow, and plant feedback. Question time.
Okay, just before we get onto the questions, I'll just load in the sidebar. You should be able to see that now. So that, yeah, in the sidebar, if you click the download now button, you can do that now or later. It'll open a new window in your browser, so you won't leave the webinar. It's got a lot of information in that white paper that you can grab and download from the Eagle website. So I'll just leave that there. Okay, switch webcams back on and I shall get rid of the slides. Thanks very much for that overview, Dave. Very interesting. So if you have a question while we've got Dave here, please type it in the sidebar. There is one question that I'll highlight from Jeanette. So Jeanette asks, could a fetus of a pregnant woman be affected with the X-ray machine if she works nearby to the equipment?
And the answer to that is no. Generally, the way the machines are designed, you have to be right on top of the machine.
Okay. So yeah, I mean, a pregnant woman would be considered high risk, you know, in any workplace, you know, and duly protected, even more so than other individuals. But Dave, you know, in answer to the question, Jeanette, no, categoric. Okay, question from Ahmed. So thanks for the webinar. If you could summarize the difference between X-ray and metal detector, is that in your, could you do that, Dave?
The advantage of an X-ray system over a metal detector is that it detects more than metal. There is some good metal detectors out there, and I'm sure Eagle produced some good ones as well. But basically, they don't detect everything, and that's where X-ray comes in its own. It detects more than just metal.
Yeah, for sure. Question from Randall. How common are product jams, primary cause of jams? What products are more likely to experience jams?
Right, product jams are generally caused by the product handling system. It's important that when you present the product to an X-ray machine, you present it as square as possible with reasonable spacing. Generally, where most of the product jams occur is when something downstream causes a backup on the line and product gets put on top of each other. On a good, well-spaced line, it's quite rare, but if you've got production variances on the line, you can expect to have a few product jams.
Okay, and just Randall asked a further question. Do jams create an issue with radiation exposure?
No, they don't. Most machines, if the line stops completely, the X-ray machine will actually switch off. If it's not seen any product moving under the beam, it shuts itself off, mainly because it's indicating a problem and the machine says, oh, what am I going to do? Let's switch off completely.
Yeah, got it. Okay. Let's see if there's any further questions. Yes, the slides, recording and certificate will be emailed to you later and you will get a certificate, yes. Any further questions? Okay, question from Rachel. Can any company do calibration for X-ray machines? So are X-ray machines calibrated for a start or not? Or
Generally not. There is calibration that we do on various types of X-ray systems. That is because they have special functions. In the case of our FA ranges, we would do calibrations to ensure that the CL category remains accurate. That's meaning we're accurately measuring the fat inside the meat content that's on the belt. All right, so that has to be calibrated against the standard. Some of our newer detectors also have additional calibration, for instance, when we're doing poultry bones, so that we can calibrate it so that it can give the customer the best cover of what he wants to find.
Yeah. Okay. Question from Mofan. Any recommendations for retesting? If we found foreign material in a package of food product, does it mean this bag needs to be destroyed, or are retests needed? If retest is needed, how many times do we need to rerun the product to consider it a pass?
Generally, what most systems that we use today, it goes into a reject bin, and normally the quality guys come along at a later date and they will repass those product back through the machine. So they will give it a second pass. And if it rejects again, those products are then generally destroyed.
Okay. Okay, I can't see any further questions at the moment. Oh, yeah. Patricia, do the shields on the inside of the X-ray machine protect the product, or does the product get exposed?
The product gets exposed, but X-ray does not affect the product. The levels of X-ray we're using in our machines do not affect the product in any way. It's not like other systems like irradiation of product. Now, those are used to sterilize products. And of course, our machine probably uses 1/10 of the power that they do. So the answer is no.
Okay. Question from Alaris. If your products are not homogeneous, X with meat bits, ligaments, and peppercorns, can you set the X-ray to detect plastics, example, polythene bags?
Yeah. Polythene bags are quite difficult, but in most cases, it depends on the type of polythene bag. We would have to set up a machine to screen for that particular type of polythene bag that was likely to be there.
Okay. Question from Angela. What is the best indication that the machine is not working well?
When it stops, generally, if you start to find that everything is going through and you're not getting any rejects, it's normally an indicator that either your process has improved so much that you're not getting any rejects, or that the X-ray system is not seeing them. But generally, most processes you expect to get some rejects. It's in a lot of cases it's quite low, but that would have, when you had the original installation and set up your programs, that would have been explained to you in the very beginning, and you would have you'd have an indication as to how well it should work. We also recommend that you do regular checks, probably once per shift, to make sure it is detecting the contaminants it was designed for.
Okay. Question from Walter. Is there a correlation between the machine's sensitivity and voltage current?
There is a relationship on the X-ray power and the sensitivity. When we set up a product, we set up a product to have the balance between the two. So the sensitivity and the voltage, the kV and the milliamps will be set up in such a way as to give us the best possible image on the machine. If we put too much power in, all it does is wash out the complete image. So we try and balance it too. It's got to be balanced to the product. What is an ICD? I can't hear you, Simon.
Yep, sorry. I'm just saying I'm not sure what ICD is. That's just ICD heart device is to treat people with dangerously abnormal heart rhythms, sends electrical pulses to regulate abnormal heart rhythms.
Now, all our machines are EMC tested to make sure that this doesn't occur. There's no device out there that we're aware of that is affected by an X-ray machine.
No.
As long as the X-ray machine is not being tampered with in any way, shape, or form.
Sure. Question from N. Hammer. Would X-ray be a good tool to detect foreign material in packed cases of folding cartons?
We do use it for that. We have machines that do, especially carton packages. A typical example we had the other year was a company was producing potato chips or crisps in the UK, and they were testing it in bulk packets, bulk containers of multi-packs of crisp, and that's how they were testing it. They weren't doing it in individual packets. They were testing the bulk packs ready to go.
Okay. Mehdi is asking, in which food industry can the technology be used? It's a wide range of applications, isn't it?
Generally, it's in most areas of food and pharmaceutical. We don't really have any limitations.
Okay. Question from Alaris. If your product has an insert sauce, packed barbecue sauce inside a pack of nuggets, can you set the X-ray machine to reject the pack without the sauce pack? Right. So if you don't put the sauce pack in with the nuggets, can it identify that?
Yeah, we use a facility called the missing item facility, and basically it's looking for a sauce pack, or in the case of chocolates, where you chocolates in a tray, you're looking for missing chocolates. It can do any of that. It expects to see a pack there. If it's missing, it will reject.
Yeah, very good. Moffan, is there any concern for my company to issue a radiation-free statement if we use X-ray in our production? We are located in the US.
No, you don't, because the X-rays we use, as I said earlier, we are not the kind of X-rays that affect your food.
Yeah, maybe people get confused with irradiation and X-ray radiation.
Yeah, irradiation, you have to put a sticker on your food. But you're removing impurities. You're not inspecting for things inside it.
Totally different. Randall, are different energy levels used for different products, or is there a standard energy level that is standard in the food industry?
No, our systems will allow you to program for a series of different foods on any particular line, depending which product you're running on. I mean, if you're running meat products for different, for example, there is a difference between steak and lamb, or beef and lamb on a production line. They generally would be run as separate items at a different time after cleanup. But there's a significant difference, and the energy levels would be adjusted accordingly.
Mofan's asking another question. Do you have a recommended sensitivity for dry powder products, for example, baking mixes?
If you go onto our site, I'm sure we've got some customer examples on there, or tests of that sort of thing. I can't remember off the top of my head what they were called, but yes.
Okay, check the Eagle website. Katja, do you have a recommended no, sorry. Try again. Must we recalibrate per product type and per product package size? Can this be done by staff?
Once you've created all your programs, the programs exist in the machine. So when you change product, all you do is you change the product on the machine, and everything that you've stored for that machine will already be there.
Yeah.
So you will have stored the product size, etc., and what it's looking for. So all they do is select a new product type.
Yeah. Okay. And can X-ray be harmful for oil or fat in food?
No.
No. It's not harmful at all for anything. So
yeah, it has no effect on the food at all.
Yeah. Okay. Any further questions? We have got time, but if not, okay. I can't see any more questions. If you do, you can always send them through. I can pass them on, and we can do them via email. But yeah, for now, yeah, great presentation, answering some questions that people get confused quite a bit with, actually. There's another question. Randall, what is the high-end kV setting or max energy level in the EPI machinery?
140 kV is currently max setting, and that's basically most of the FA series machines. And that is primarily because they're doing meat products.
Okay. Can't see any more. Yeah, John says interesting and informative. Mofan, thank you. Yeah. Yeah, I think that's it. So thanks very much for your time today, Dave. Enjoy the sun. Maybe get yourself a cold drink. And yeah.
I'm already thinking about it, Simon.
Well, nice to have you along, Dave. I hope to have you on one of these again in the near future. So thanks for your time.
Simon.
Have a great weekend. Cheers.
Okay, bye.
Okay, that's Dave Leith from Eagle Product Inspection. I'll put your certificate in the sidebar that you can download now, and you can print and sign it, or you can open it in an image editing software like Microsoft Paint and type your name on there. There's various ways to do it. We can't personalize them for you because it would just take too long. So thanks for your attendance today. We've got another webinar next week with Cor Gronfeldt from FSSC 22000. And we're going to be talking about what makes a food safety management system effective. So FSMS effectiveness. I can't even say it. So yeah, that'll be good with Cor next week. He's a very engaging speaker, so we'll look forward to that. In the meantime, enjoy your Friday. Enjoy the rest of your day. Have a great weekend, and we'll see you next Friday. Take care, everyone. Bye-bye.